Hello everyone, welcome to my channel IGCSE and GCSE Maths School. This channel posts videos daily on mathematics for you to pass the examinations such as Cambridge, O-Level, Edexcel IGCSE, GCSE.SAT, CAT, PSAT, NMSQT, and other parallel examinations. I am Saman. We are doing a lot of videos now. We have done a set of videos already. We have finished the rules of operands of directed numbers. Then we have started the new series that is the rounding of numbers and upper bound and lower bound. Now in that series, in the present series also, we have done several videos, and the previous video was on how to find the upper bound and lower bound, and what is upper bound, what is lower bound, and range of actual values that can be rounded to a given corrected value to a given degree of accuracy. So we have discussed the very basic concepts of the upper bound, lower bound, and the range of values that can be corrected to a given corrected value to a given degree of accuracy. Now today we are going to discuss, and in the previous video also we discussed some simple examples. That was some simple examples that was to find the upper bound and lower bound of the numbers corrected to nearest unit, nearest 10, nearest 100, and nearest 1000. Now today we are going to look at how the upper bound and lower bound is found with regard to the numbers which have been corrected to decimal places. If the corrected value is correct to a certain decimal places, then how to find the upper bound and lower bound of such corrected value. Right. Now there are three important things, three important points that we have to note down and take into serious note when you find the upper bound and lower bound of a number corrected to a certain corrected to some decimal places. It can be a number corrected to one decimal place or two decimal place or three decimal place. Mostly they are actually the degree of accuracies in decimal places that are given at examination. Beyond the three decimal places, it is very unlikely. Therefore, we limit our study to restrict our study to only the upper bound and lower bound of the numbers corrected to first decimal place to third decimal place. Right. Now, if the number has been corrected to, now you know actually. Now you know actually, we during the last video we discussed how to find the upper bound and lower bound. We discussed two formula for finding upper bound and lower bound. One formula for finding the upper bound, other formula for finding the lower bound. That is, what is the upper bound formula? Upper bound formula is upper bound formula. Upper bound equals in that formula corrected value plus the degree of accuracy over 2. Degree of accuracy over. So that is the upper bound formula. This is universal formula that can be applied to find the upper bound of any corrected value. Therefore, it can be applied to find any upper bound of any corrected value. Right. Okay. Now, irrespective of the syllabus, this can be used in almost all syllabus. Right. Okay. For the next one, then upper bound correct equals is found by this formula corrected value plus degree of accuracy of 2. Then lower bound of a corrected value is corrected value minus degree of accuracy over 2. So these are the two formulas. This is the lower bound formula. To find the lower bound of any corrected value, you have to use this formula. These formulas are usable in the syllabus. Right, okay. Now, so these are the, we have to use these two formula for finding the upper bound, lower bound of any number, right? Okay, now if the particular number has been rounded to one decimal place, then the degree of accuracy that should be put in the formula here is 0.1. If the number has been rounded to one decimal place, the degree of accuracy is 0.1. If the number has been corrected to two decimal places, then the degree of accuracy is 0.01. The number has been corrected to three decimal places, then the degree of accuracy that should be used in the upper bound and lower bound formula is 0.001. So these three important points should be noted down. It must be taken very serious note because they are applicable in finding upper bound and lower bound of the numbers that have been corrected to decimal places. Then these degrees of accuracy depend on the place values. Then when the number is rounded to first decimal place, then place values first decimal place. That is, its degree of accuracy is 0.1. If the number is rounded to two decimal places, then the place value of the degree of accuracy is 0.1. Second decimal place. If the place of the degree of accuracy, second decimal place. That is 0.01 is the degree of accuracy. When the number has been corrected to three decimal places, then the place value of the degree of accuracy is third decimal place, and the degree of accuracy that should be used in the upper bound and lower bound formula is 0.001. Then if the number has been corrected to one decimal place, then degree of accuracy is 0.1. If the number has been corrected to two decimal places, degree of accuracy is 0.01. If the number has been corrected to three decimal places, the degree of accuracy is 0.001. So that is the important point in this regard. Right, now, next one. Now there are several examples where we will see. Now there's a question. Now what is today's video? Today's video is on finding upper bound and lower bound and the range of actual values that can be rounded to the given corrected value, the given degree of accuracy. When the numbers have been corrected to decimal places, right? So that is what we are going to do in the video today. Right, now see, now in this one there's a question. Find upper bound and lower bound of each corrected value and the range of actual values that can be rounded to each corrected value. I couldn't speak about the range of actual values, right? What are the range of actual values that can be rounded to the given corrected value, given degree of accuracy? So last time, the last video, I have mentioned that range of the actual values that can be rounded to the given corrected value, given corrected value to the given degree of accuracy. Then it is like this. You may remember, right? If you watch the last video, you may remember. Otherwise, you watch that video. I have mentioned that link in the description below, and go to the link and watch that video and come to us. Otherwise, if you do not know what the upper bound and lower bound is, it is there will be a question in you with you always about what we are doing, right? Then next one. Then there's the other important part is the range of values. Range of values that can be rounded to the given corrected value to the given degree of accuracy, right? Now, range of values. How do we find the range of values? The range of values, this is the range. Range is always in this format. What is that? You get lower bound here, lower bound, and less than or equals this actual value, less than upper bound. This is the range. These are your range. Therefore, after finding the upper bound and lower bound of a corrected value, then that corrected value will be a representative value for every value in this range. Every value in this range. Then if you round any value in this range, any value greater than or equals lower bound, but less than upper bound, you will get that same corrected value. Then any value in this range which is greater than or equals lower bound, less than upper bound, can be rounded to that given corrected value. That is the idea or the meaning of this range. Right, okay. Then we will go to the examples. There are several examples we have to calculate, right? Then I will write this formula here, upper bound, because I want to take that space, a corrected value plus degree of accuracy over 2. Lower bound, corrected value minus degree of accuracy over 2. Then range, for the range, lower bound less than or equals actual value less than upper bound. The range means the actual values that have been rounded to the given corrected value lies in this range. That is it. Okay. We will work out these examples, right? Now there's a question. Because find upper bound and lower bound of each corrected value and the range of actual values that can be rounded to each corrected value. These are each corrected value. If corrected value is this one, right? Then if the corrected value is any of these, then find upper bound, lower bound, and range of actual values that can be rounded to each corrected value. That is the question. Then this part in the examination question, this part is not given, right? That is what I wrote for our convenience, but this must be your knowledge. You must have this knowledge from your study of this lesson, this part of mathematics. You must have that knowledge. You must go to the exam with that knowledge, and you must have this knowledge also. This is also not given at this. You must have this knowledge also. That is your knowledge. And you will be given questions like this, and they will ask find the upper bound, lower bound, and the range of values that can be corrected to that given corrected value to the given degree of accuracy. Right, now see. Now this one, right? Then, right. Now we will find those three for each of these corrected values. Right, the first one. Now the first one, I will take upper bound. Now say in this one, 2.56 is the corrected value. 2.56, what is the upper bound? Corrected value plus degree of accuracy over 2, right? Now 2.56 is the corrected value, right? The corrected value 2.56. Then what is the degree of accuracy? There's 2 decimal places. 2 decimal places, degree of accuracy is 0.01. 0.01. This divided by 2. Then how much is the answer? Answer will be 2.56. When this is divided by 2, 0.005, then it will be 2.565. This is the upper bound. Now lower bound. right? Right. Lower bound. What can you say? Lower bound. Lower bound. How do you find the lower bound? Lower bound is bounded by corrected value 2.56 and minus degree of accuracy over 2. Degree of accuracy is 0.01 over 2. That means again you have to deduct this one. After dividing the 0.005, then it will be 2.56 and this will be 0.55. Yes, 2.555. So that is the lower bound of this number. Right. Now next one. Then the range of actual values. How do you find the lower bound? What is the lower bound? 2.555. Then less than or equals actual value. Less than upper bound 2.565. Okay. Now next one. Second one they ask 5.6 upper bound. Corrected value plus degree of 2. Corrected value is 5.6. 5.6. What is the correct value? Correct one decimal place. One decimal place. What is the correct value? 0.1 divided by 2. All right. After dividing 0.1 by 2, how much? 0.05. Then add that to this one. 0.05. 565. 5.65. That is the upper bound. Then lower bound. Lower bound. What is the formula? Corrected value minus degree of accuracy over 2. Right. Now corrected value is 5.6 minus degree of accuracy is 0.1 over 2. Now when 0.1 is divided by 2, it is 0.05. Then you deduct 0.05 from this and it will be 5.55. Okay. Now range. What is the range? Range of actual value that can be rounded to this 5.6. Correct to one decimal place. How much? Then range is lower bound. How much? 5.55. Less than or equals actual value and less than 5.65 upper bound. That's the rate. Okay. Now write third one. What is third one? Third one is 12.123 to 3 decimal places. Right. What is the degree of accuracy when it is corrected to 3 decimal places? 0.001. Right. Then that should be used. That 0.001 should be used as the degree of accuracy in the upper bound and lower bound formula. Right. Now upper bound equals what? Corrected value 12.123 plus. Then that one. Degree of accuracy 0.001 divided by 2. Right. Then when this is divided by when the 0.001 is divided by 2, answer will be 0.0005. Then you add those. Then you get 12.1235. Add those and see. Right. 12.1235. Right. Next one. Then lower bound. Again, what is the formula? Degree of corrected value minus degree of accuracy over 2. Then corrected value is this itself, 12.123 minus. Then degree of accuracy is 0.001 divided by 2. Then you subtract this. This will be 0.0005 after dividing by 2. Then you deduct, then it will be 12.122. 1225. 1225. Right. Okay, right. This is the lower bound. Then the range of actual values that can be corrected to this value, that can be rounded to this value, is how much? Lower bound 12.1225 less than or equals actual value less than how much? Upper bound 12.1235. Right. That is okay. That is the answer for the third one. What do you mean by this range? This any value in this range, can be rounded to 12.123, correct to 3 decimal places. That's what it says, right? Go to the next one, third. Fourth question, right? Fourth one, upper bound. What is the formula? Corrected value plus degree of accuracy over 2. Corrected value is 13.2. You take 13.2 corrected value plus degree of accuracy over 2. This fourth one has been corrected to 1 decimal place. Therefore, the degree of accuracy is 0.1. Then divided by 2, answer will be how much? Answer will be 13.25, right? That is the upper bound. Then the lower bound. Lower bound, corrected value minus degree of accuracy over 2. Corrected value this itself 13.2. Degree of accuracy also that itself, that is 0.1. That's 0.1 divided by 2. Then you subtract here. It is not addition. You subtract 0.05 from this term. So after 0.1 is divided by 2, it is 0.05. Then deduct that one. Then you will get here 13.15. Then the range, you write range. What is that? That is lower bound. You get 13.15 less than or equals actual value and less than upper bound 13.25. Okay. So that is the answer for the fourth one. Then fifth one. We go to fifth one. What is fifth one? Fifth one is 68.45 correct to 2 decimal places. If the number has been corrected 2 decimal places, the degree of accuracy is 0.01. Then the corrected value. Upper bound equals how much? Upper bound equals corrected value plus degree of accuracy over 2. Then corrected value here, how much? This number 13.2, 68.45, then plus degree of accuracy as it is corrected to 2 decimal places, then 0.01 divided by 2. Then answer will be 0.01 divided by 2 is 0.005. Then you add, then it will be 68.455. That is the upper bound. Then you go to the lower bound. Lower bound is corrected value minus degree of accuracy of the corrected value is 68.45 itself. Then minus the degree of accuracy is 0.01 itself. Then you write it here 2. Then you deduct this from this. Then it will be 68.445. So 445, 68.445. Then range will be lower bound is how much? 68.445 less than or equals actual value less than upper bound 68.455. Right. That is fifth one. Then go to sixth one. Then sixth one here, sixth one. Sixth one is 51.678 to 3 decimal places. If the number has been corrected to 3 decimal places, its degree of accuracy is 0.01. Then you take 51 upper bound, upper bound equals corrected value plus degree of accuracy of 2. Corrected value is 51.678. 51.678 plus the degree of accuracy over 2. What is the degree of accuracy? It's corrected to 3 decimal places, therefore 0.001, therefore 0.001. So that is corrected to 3 decimal places. Yes, degree of 0.01 divided by 2, right? Divided by 2. Now you divide and add, then the answer will be 51.6785. 51.6785. So that is the upper bound. Then the lower bound. The lower bound will be how much? Corrected value plus corrected value minus degree of accuracy. That's how we calculate the lower bound. Then go to lower bound. Corrected value is itself 51.678 minus 0.001 divided by 2, that is degree of accuracy 0.001, as the number has been corrected to 3 decimal places. Then you go to this one and deduct, then you are getting 51.6775. 51.6775. So that is the lower bound. Right. Then range of that. Range will be what? Lower bound is how much? 51.6775 less than or equals actual value less than upper bound 51.6785. So that is the range. Then you go to the next one, seventh example. Then seventh one. Then upper bound. What is upper bound? Upper bound is seventh upper bound is corrected value plus degree of accuracy over 2. Then seventh one, the corrected value is 6.0. Then plus degree of accuracy over 2. This number has been corrected to 1 decimal place. Therefore, degree of accuracy is 0.1. 0.1, that is divided by 2. Right. Now, you got this and calculate this. Then 0.01 divided by 2 is 0.05. Add on to this one. Then you get 0.005. That is the upper bound. Then lower bound. The lower bound will be corrected value is 6.0 plus minus correct value is found by the formula. Lower bound is found by the formula corrected value minus degree of accuracy of 2 minus degree of accuracy is 0.1 over 2. Then as the number has to be corrected to 1 decimal place, degree of accuracy 0.1. Then here you have to subtract. If you subtract, you are getting here 5.5 So I made a mistake here. Here it is after adding, it will be 6.05. 6.05. Then this one, after subtracting, you are getting you are getting 5. So 5.95. Sorry, 5.95. 5.95. That is the lower bound. Then range will be greater, lower bound is 5.95 less than equals actual value less than upper bound 6.05. That is that one. Then next one, 11.0, eighth one. Then upper bound equals corrected value plus degree of accuracy over 2. 11 point, that is 11 is the corrected value. Then plus degree of accuracy, as this number has to be corrected 2 decimal places, the corrected value is 0.01. 0.01 divided by 2. After adding this, you are getting, after dividing this 0.005, then answer will be 0.005. So that is the upper bound. Then lower bound equals corrected value minus degree of accuracy of 2, then corrected value is 11.0 itself. Then this is minus 0.01 divided by 2. After deducting these two, what are you getting? You are getting this 10.995. So 10.995. That will be the lower bound. Then the range of actual values that can be rounded to 11, correct to 2 decimal places, is then lower bound. Here the lower bound, how much? 10.995 less than or equals actual value less than how much? 11.005. That is the what? 11.005. That is the upper bound, right? Okay, that is how you find the upper bound, lower bound, and the range of actual values that can be rounded to the given corrected value to the given degree of accuracy. That is all about today's video. Video is a little long, but there's nothing to do. That's how you have to do. You have to practice this and again do these questions and practice the examples and gain very good knowledge of finding upper bound and lower bound of the numbers corrected to decimal places. Okay. Before ending the video, I must tell you this channel, we post videos daily on mathematics for the wide range of examinations that I mentioned at the beginning of the video. So therefore, stay with us and subscribe the channel, like, share, and comment on the videos. Then until we meet tomorrow, we are bringing another interesting video tomorrow. Until we meet tomorrow on another video, say goodbye to you.